2011.
Yeah. It's 1976.
Okay. That's strange in its own way.
Yeah.
So,
Yeah.
you get something like that right, yet something
Yeah.
that should be a little more obvious,
Yeah.
so wrong. I mean, hell, yeah, how old were you in 2011? You would have been, you know what I mean? You would be high school graduation age.
8 years ago.
Yeah.
What, 52?
Yeah, well, I'm just, you know.
Obviously, someone's not very good at math.
Yeah, I don't know. That is weird. So it's funny because they put these security, quote unquote, screws on here.
Yeah.
So I'm demonstrating that with a simple pair of pliers that you can defeat the security screw quite easily. See, the other microwave, it only had 2. All the rest of the screws were regular screws.
Yeah.
So once I got the 2 off, it was easy. This one, every screw holding the case on there is 1. So it's going to take me a few minutes longer. Whoop-de-doo.
Alright, well, don't release any bad stuff.
Well, I was going to say, because now I can sue them after I get shocked and die, or just hopefully I won't die, because then I could sue them.
Well, I'll sue them for you.
Okay, that's fine. Because, you know, they, you know.
My 40-year-old son. It's actually quite smart. Decided to.
Well, I thought he was smart.
I would expect something out of Tyler or something. Try to take something apart like that.
Well. Yeah, it's fine, Mother.
Huh? I'm watching Jack Whitehall. He's an English comedian.
Oh, yeah?
But he's going on these trips with his dad.
Yeah. He told me a little bit about it the other day.
He and his dad are just opposite as far as interests.
God.
His dad's an old man.
Yeah.
Anyway, pretty funny.
I was watching a YouTube channel, the guy that he really likes to play with sparks.
Oh, yeah.
I mean, I think they're interesting, but it's really not, I don't know, something necessarily going for exactly.
Right.
But yeah, he makes all sorts of crazy stuff. He made a transformer that put out like a half a volt, but it like some stupid amount of amps, like you know, tens of thousands of amps or something like that. So he could take like a huge big metal bar and just short it across this transformer, and it would just turn like red hot in like 15 seconds.
No, no.
So yeah, it's like wow, that's a lot of energy right there.
It just, yeah. Well, I could have used that microwave, but it's too late now.
We just bought a brand new one.
Well, we can have one in reserve.
Well, I mean, if it really gets down to it, I guess I could. I mean,
I'm just teasing.
I could I could save the case and everything. I could put it back together.
I'm just teasing.
I mean, whatever I'm taking out, I'm not gonna dance. You know, unless something goes wrong, it's not gonna damage it. All right, almost in there.
All right.
So I'm throwing these screws away because they're stupid. What?
I gotta find the cat. I haven't seen him lately.
Uh-oh.
Alright, I'm gonna go back to the...
Oh, damn them. We got a hook. Oh, there we go. Uh-oh. I think they finally got smart on this one. They put it in a recess. Aha. Yeah, I'm not sure if I can get a hold of it. Oh, no, I can get it. cannot defeat the Nipix. I'm telling you, man. They could have. If they would have put it a little more recessed, a little tighter of a recess, then yeah, pliers wouldn't work too well. But it wouldn't stop me. I have many methods of bolt and screw extraction. Oh yeah. Bitch. Long-winded here, huh? Their other security method is make this one like 6 inches long. No, they didn't do that. It's the same length. Oh. Alright. Oh, look at there. See. Let me go get my flashlight. Did you find a kidney? Oh, there we go. Okay, I got my flashlight so I can see some shit. And what do I see? Not sure. Oh, there we go. See, just gotta give it a little bit of force. Yeah. Well. Shorter. It's got a much simpler looking board than what I currently have. Similar switch arrangement though. The door operates similarly. Yeah, transformer looks to be the same size. That's weird. I don't see a diode. Oh. There's maybe one there. See that or a resistor? Huh. So I thought, so maybe it's 2 diodes. Like that. Huh. I'm not sure. Let's see, there's this thing, which I thought it was a resistor, but now that I'm looking at it, I think it's a diode. So, Yeah, magnetron looks the same. It's even got the same little input filter board. So, yeah, we got, interesting. Thermal switch is kind of dangling off of it. You'd think they'd want it mounted closer, but I guess that's how they calibrated it. Another one over here. Oh yeah, that's our bulb. And what else? Oh, this one's, yeah. Got a little, it's weird. Little board that hangs off here. It's just got some capacitors and I don't know what that is. It says DuPont. Same kind of fan motor. So yeah, very similar construction. Yeah, once they, I guess, got a design that works, they don't change it too much. It must not be patented by any one manufacturer or whatever, because this is a different brand. This is a Frigidaire. So, I am curious about the Alright, so this is going to be the home, the final home of the transformer. There's the other fan. So yeah, here's my old transformer. As you can see, it's wow. It is practically identical. Yeah, I mean it is unbelievably similar. Awesome. So yeah, that's what I wanted. Pretty much a match pair. So yeah, this one has the. It is a diode, I'm pretty sure, now that I'm looking at it. Because it's just like the picture of the diodes that you can buy. That I bought on order. So I actually have, then, 3 diodes, I guess. So, I also have this thing here, which is a 5 kilovolt, 0.5 amp. I'm assuming this is a diode. I haven't actually checked it, so hell, it could be a resistor, although I don't know why you'd want a resistor. I think it's a diode. Hell, I need to check it, I guess. I know that these are diodes now, so I have at least 2 diodes. But like I said, I'm going to be getting a bunch more. So, and this is also a Oh no, this is a 1 UF 2100 volts. That's a .95 2100 volts. So they should work alright. But I think from the video that I saw, I think I want to get more caps, or probably just make my own bottle caps, I guess. Yeah. Because caps are not cheap. They want like, well, they're not that expensive. They're like $4. I mean, you know, from China. Of course, you gotta wait a few weeks. The bottle caps you can make, I think, are at least 2100 volts, probably rated. I mean, they use them on Tesla coils, so. So yeah. So I do like the fact that, you know, I have these thermal switches. I probably will incorporate that into, you know, this. Now this is going to be, you know, these will be in here, caps will be in here, you know, anything that's going to be at the high voltage will be in here, and then I'm going to fill this with oil, you know, so everything is submerged in oil. That way, you know, it keep down any corona that might form, and it'll just help to dampen vibrations in the cores, which helps to improve their efficiency, and this will act as a heat sink, because it'll, you know, the heat that develops in here will be able to spread in the oil, and then will be able to be radiated from the pot. So I'm building another what I'm calling a mid-voltage power supply. I want to max it out about 400 volts. You know, I'll probably have that in another pot. And then I was thinking of then making an enclosure and mounting these fans in such a way that, you know, it draws air across the pots and keeps, you know, so the heat that's being collected on here will then re-radiate into the air and out. So in theory, if that works as well as I hope it will, I should be able to run them, you know, continuously for a long time without any issues. That's my hope anyway. So, okay, I'm understanding that. Yeah, see, I was hoping that it was going to have another one of these too, but, you know, beggars can't be choosers. I went to, I went to the pawn shop here in town. They just had a little microwave, which I guess if I really wanted to, I could, because the little ones seem obviously more available. And they're cheaper. I mean, they only wanted like $20 for the little ones. I mean, in theory, they should be put out the same voltage, just probably not as high of amperage. I'm assuming the transformers are smaller. So I might think about getting maybe a couple of the smaller ones, making a, a secondary high voltage source. So anyway, I don't know. Maybe I may have plenty. Yeah. All right. So I guess the first thing to do, we got it since when I was at the pawn shop, I wanted to make sure that it worked. I didn't want to buy something that was broken. So obviously I had to put some water in there, and I turned it on for a minute, and the water got hot, so I figured, hey, it works pretty good. Anyway, so the capacitor very well could have a charge on it. So I'm trying to see here. I think if I can get to the leads here. So that one probably should be shorter. Not sure which way that diamond is going. This is a magnetron. I think I told you that on the other video. So this is high voltage wire. Show you what it looks like. Maybe we can see this. I don't think it knows what to do with that. Focus up close. I've never tried to focus up close. Yeah, it doesn't want to do it. Well, anyway, it's basically a very thin, kind of a woven cloth outer, it's red bit, and then, oh, there we go, you can kind of see it there. If I hold it off center a little bit. Well, anyway, it's, and that's a white, some sort of a white substance. And then the wire is a pretty thin, solid, just a single solid strand in the center. So, it got me thinking that, hey, I know something that looks like that. That's your regular old coax cable for your cable television. Of course, it has a metal braided cover underneath the whatever plastic outer cover. So, in a way, it's even safer potentially than this for high voltage, because if you set it up right and you ground that outer braided sheath, which you're supposed to anyway for regular setup, if the voltage leaks from the center conductor, tries to get out, it's going to find that ground path that's the coax, and it'll just go there. So in theory, it shouldn't be able to jump out of the wire unless it's really high voltage, or your ground isn't very good, or you're got a real long run of cable or something. Some reason why it would think that would be a better way to go than along that other path. So that's what I want to use for my high voltage cable is coax cable. So I know people are probably going to tell me I'm crazy and stupid, but whatever. I mean, the only other, because I'm an automotive tech, I work on cars, and they have ignition coils, which well, I have some over here. These are from a I don't know, early 2000s Toyota Camry. Anyway, these are cool because you can't see, of course. Some auxiliary lighting. Oh, that looks weird on the camera. It looks real blue on the monitor, anyway. As you can see, these have 4 terminals, and they actually have the driver built in. So I'm trying to figure out exactly how it works. I mean, you have a power and ground, and then you have your signal, and then there's the 4th pin, which I'm really not sure, because it splices together. I mean, from the 4 coils, and then goes back to the computer. I'm thinking it's just a feedback signal, and the computer's able to differentiate the feedback based upon the timing, so it knows when it sent the signal based upon, because each coil has its own signal wire, independent signal wire, so it knows when it's fired the coil, so it should know on that return signal when it should see that return signal. So, I mean, that's assuming that that's what it's doing. So, in theory, that you don't need that. That's just a diagnostic terminal, basically. So I think that, if I just feed power and ground and then trigger that 3rd, trigger pin, and that's what it's called by Toyota, is a trig pin. It's one of those. It should fire. So no other, transistor driver circuit needed. So that's, if that's true, that's really cool, because that's kind of been a deal, as I would have to build, I needed to get higher voltage rated MOSFETs, because the ones I have are only rated to, 40 volts or something, and you need to drive any kind of inductive load like that, you need something and it's hundreds of volts to be able to handle the kickback. Which, I should probably still get some MOSFETs, high voltage MOSFETs, but for now I can use those coils, I'm hoping. So yeah, I'm basically going to have, I also have the flybacks from the TVs that put out close to what those put out. But, yeah, I'm not sure exactly how I'm going to drive those yet. With these, I can drive with my 555 circuits, and I can, in theory, create, different frequencies and different types of spark discharge by varying the pulse width and all that to the, maybe, I don't know. It may just take, any kind of step, and then in a certain time period output a spark is maybe what they do. I don't know. So it may be, it's still going to respond to frequency, but it's probably going to have a limited bandwidth, because it's probably, if you try to go too high of a frequency, it probably won't work anymore, I'm assuming. Because the car engine only goes to a certain RPM, which means that the sparks only have to fire at a certain rate, and you want the maximum spark energy. So you would design it to where, at the highest RPMs that you would run, you could still maintain enough spark energy to fire cylinders at in those conditions. So anyway, Enough bullshit. Let's get this fucker torn down. Alright. So this one also was not, they weren't nice, and have a diagram printed on the case. But it's pretty obvious how they work, so I'm not too worried about it. Okay, so that's not even. I see. So yeah, so I could just like epoxy that, or yeah, I mean I could use that flange to attach it somehow. So I'd have to look it up, but it's a KSD 201, and then it's got 160. That one, which was right on the magnetron, and then the one that was on this case is a KSO 201 120. KSD 201. Yeah, so it's the same 6 numbers.